Lissa Productions.
Today we're going to talk about the topic of filters. The idea is we have some input voltage that goes into some circuit and we get some output voltage out. And one thing that's important to keep in mind is that the frequency of the input voltage and the frequency of the output voltage are the same. However, the amplitudes of both of these can change, and that's how we define the gain. You just remember the gain is defined as V out over V in. And that is, in principle, a complex number. We talked about a Bode plot. We have to measure the magnitude of that and the phase of that. The other things that can characterize this is we can look at the input side of this, and it looks like some input impedance, Zin. Remember from the voltage divider, we had an input resistance, which was just the sum of the two resistors in series. Same thing here. On the output side, we have a Thevenin equivalent, so we have the output voltage equals the gain times the input voltage, and we have an output impedance, Z out. So there's three complex numbers, the gain, Z in, which can depend on the frequency, and Z out, that can depend on the frequency, that can fully characterize this particular filter for us. Now in this course we talk about filters that are a little bit simpler, and so let's take a look at what we're talking about in this course here. So in this course we have the gain, the input impedance, the output impedance, and a typical filter is made up of some components, Z1, Z2, here's the input, V in, and here's the output. And the Z1 and Z2 can be resistors, they could be capacitors, they could be inductors, they could be more complicated combinations of those, but they're basically something we can represent like this. This circuit, if we look at it for about 1 second, it's just a voltage divider. It's AC voltages with impedances, but it's just a voltage divider. So we know immediately the gain of this circuit is just going to be Z2 over Z1 plus Z2. We don't have to do anything else. We've already solved that. So if we know Z1 and Z2, we know the complex gain of this circuit. We also know what the input impedance of a voltage divider is. Zn is just the series combination of Z1 and Z2. We're done. We've got it there. The last thing, the output impedance, well, that's the Thevenin equivalent of this. That's just the parallel combination. Z out is Z1 parallel Z2, which we can write as Z1, Z2 over Z1 plus Z2. So filters that look like this, that we can represent as basically our voltage divider, we've already solved it. We've done that with DC circuits. The gain is just the voltage divider output, input impedance, output impedance. We can fully characterize that circuit. We can go and measure that in the lab, make a Bode plot, measure the input impedance, the output impedance, and compare it with what we expect. So that's the basic picture of a filter here.